This is a hot ice experiment presented to you by Martha Basilio and Rosinda Scalia.
Today we will be showing you how to make hot ice. Like shown on the screen, we will be giving you step-by-step directions while also explaining the reactions that occurred throughout the video.
For this experiment, you will need a hot plate, vinegar, a pan, and baking soda. Some other materials include a tablespoon, some plastic wrap or aluminum foil, and a clear cup.
We will start by pouring half a liter of vinegar and 1.5 tablespoons of baking soda into the pan.
When we poured the baking soda into the vinegar, we instantly noticed a chemical reaction. The baking soda and vinegar reaction are actually two separate reactions. The first reaction is the acid-base reaction. When vinegar and baking soda are first mixed together, hydrogen ions in the vinegar react with sodium and bicarbonate ions in the baking soda. The result of this initial reaction is two chemical reactions, carbonic acid and sodium acetate.
The second reaction is a decomposition reaction. The carbonic acid formed as a result of the first reaction immediately begins to decompose into water and carbon dioxide gas.
We mix the two substances to make sure that the baking soda dissolves well into the vinegar.
After we get done mixing, we set the pan on the hot plate and boil for about 45 minutes. We stopped when we noticed crystals forming on the side of the pan and about 90% of the solution was gone.
Another reaction has occurred. We see the formation of sodium acetate on the side of the pan. Sodium acetate is a salt that crystallizes both on its own and in combination with water molecules. These compounds are called crystalline hydrates, and the water in their composition is called water of crystallization.
One of the most common properties of hydrates is their relatively low melting temperature or melting point. When a crystalline hydrates melt, water breaks away and starts acting as a solvent in the resulting solution. When the sodium acetate reaches its melting point, it forms a solution even at slight heating. The resulting solution is supersaturated. This means the amount of sodium acetate in a given volume, in this case the pan, is higher than that if we need to dissolve sodium acetate in water at room temperature.
Next, we poured what was left of the solution into a clear glass container.
At this step, you will notice that the substance is a clear goldish liquid substance.
After that, we used plastic wrap to cover it up to make sure no more of the solution evaporates out, and also to prevent anything else from getting inside.
When you've wrapped your solution, place it in the fridge for about 20 to 30 minutes. But if you have more of the substance, you will need to let it cool for a longer time. When the solution has cooled, you take off the plastic wrap, and this is where the fun begins.
With a toothpick, we scraped off the sodium acetate crystals from the side of the pan to start forming the hot ice.
Another reaction has occurred, crystallization. We then place the crystals into the solution and notice that the crystallization began to occur even with a split touch of the unsaturated sodium acetate solution.
Thanks for watching our hot ice experiment.